Hear me well? And this session is being recorded. All right. So I hope everyone is feeling well and enjoying summer. It's kind of warm these days. So next thing you will see is my screen. All right. You all can see my screen, right?
Yeah.
Perfect. So okay. So let's resume from where we left last time, um, which is we were looking at strings. And before we go forward, let's quickly kind of go over and refresh our memory on what all we learned, just to build the base. So we looked at four pillars of OOPS: abstraction, encapsulation, inheritance, and polymorphism. And we kind of briefly went over them. Abstraction is kind of showing what's necessary rather than showing everything. So people don't have to know how your class has been implemented. They can just use it without knowing it. Encapsulation is wrapping all the relevant data along with its methods into one entity, which is essentially a class. Inheritance is to borrow or reuse a code that has been already written in other classes by inheriting them. And polymorphism is having more than one ways of doing something similar. Maybe like overloading and overriding are like kind of two types of polymorphisms. We'll in fact come back to these four pillars later towards this end of session today, because every Java developer should know these are the foundations for Java language by itself. So we'll spend some more time, and spend some more time writing program rather than learning theory. But strongly encouraged, you all should go find some time and deep dive into it. It's expected out of every Java programmer to know. Anyhow, so we moved on and we kind of looked at what packages are in Java, how all classes are kind of put under certain logical directories called packages, and one of those Java provided class is string, and that's what we started looking at. And string is inside the Java lang package, which contains a lot of other classes, and it's kind of a good exercise to just go and explore and what all classes are available in Java lang. And the easiest way is to, in your IntelliJ, you can press your control key and go to string and kind of find out what's all around string available there. And you'll see there's math, there's integer, long, number. So there's so many things that we can use out of the box that Java has to provide. So when we started looking at string, we realized strings are they're kind of sequence of characters essentially, one after the other in memory. Example, hello Java is a bunch of characters sequentially placed in memory. And why is string important? Because it's used everywhere, almost everywhere in our daily life. So it's very easy to get it wrong. So Java provided a class to make it easy for us to use it without worrying about how strings are internally managed by Java. Um, we also looked at we looked at Java package. We looked at ways to declare string. So there's one way to declare string is to have a type as string variable name and assign it to null, which means we have declared the string, but we have not initialized it yet. There are two different meanings to it, and then we looked at two ways to create a new object of string type, instantiate it essentially. One is using new operator, which we have done like in our prior sessions when we created a new person Joe. So new is as an operator provided by Java that lets us create an instance of a class. So in this case, string greeting is equal to new string is creating an object of type string, and this string happens to have a constructor which takes a parameter, and we pass a parameter hello. So the greeting string actually contains, it starts with containing hello in it. There's another way to create a string object, and that's called a literal way. So you can have string greeting is equal to hello in double quotes, and Java will create a string object out of that for you. Um, in either case, the string object is created in memory by Java. So okay, moving on. String objects are immutable, which means once the objects are created, every operation that we perform on the string object will result in a new string rather than modifying the existing string. So we'll look at a very neat example as we proceed further, and it's a very subtle concept. We'll try to understand it. We wrote a program and we
Oh, I have a
explained it.
question.
Ooh, yes.
Uh, are there any differences between like the operator and the literal for the string?
There is a very subtle difference. Not much for practical uses, not much of a difference, but there is difference, and it's good to know the difference, which we will cover as we go further. Today we'll write a program and kind of try to understand what the difference is. Um, I can try to explain it now, but it'll make more sense once we write a program,
Okay.
right? So we'll cover that today. But hold on to that question, just in case if it doesn't get answered, remind me of it if I forget. So we wrote a program to declare string in two ways, new and literal. Then we learned about string concatenation, which is we added two strings together. We added two string variables together. We added a bunch of other variables to a string, like integer, double, and all that, and saw how easy it is to add, like it's concatenate string. It's essentially a simple addition. Um, we also looked at a case here wherein instead of doing an addition, Java converted everything into a string, which was actually not desired. So again, the order of precedence comes into play here, and we realize how important it is in case we get those kind of bugs where we expect a different output, but Java spits out something else. Probably there's going to be some problem with the precedence. We also looked at escape sequences. So escape sequence is a special character, which is the backward slash. It assigns a special meaning to the character following it. So we looked at how a backslash n results in a new line, and how backslash t is for tab, backslash double quote is to add a double quote in the string, and if we need to add a backslash, we have to kind of escape it with a backslash. So we learn all that. We'll use it more as we proceed further in the AP coursework. We looked at adding ways to add space in a string as well. So this is where we left last session, and now we'll resume from here. Do you all have any question before we proceed further? All right, I think that sounds like no questions. So let's move ahead with today's session, and let me just skip through these bunch of animations. We look at string methods. Now, string is a class, so it may have some methods. In fact, there are a lot of methods in string, and but as part of AP coursework, we are not expected to know all of them. What is expected out of a student know is the methods that we'll look at. But the good thing is, you don't have to memorize it. The methods are named in a way that it makes sense to understand what exactly it is doing. And also in the exam, you'll be provided with a reference sheet which will have all the methods listed there. So you can literally use it from there. Um, so what are the covered AP methods? One is int length, and when you call this method on a string object, it will return you the length of the string, which means how many characters are there in the string. Another method we look at is string substring, which takes two parameters, integer type from and integer type to, which means this method is going to return a string back given the indexes between, like, given an index. So essentially, when we say, when you want to clip out a substring from a given string, this is how you'll do it: is you'll call the substring method on it and pass a start and end index, and it'll return you all the characters between those two indexes. But the catch here is the from is inclusive, which means if you say from index 0, which is beginning of the string, then it'll actually take index 0 as a starting point. But when you say 2, let's say 10th character, it'll actually return you whatever is at 9th index. So 2 is excluded. Another way to get substring is using this another method, same name but different parameter. So it's an overloaded method here. What it says is, give me substring until whatever the index we say. It means it assumes that you want it from 0 to the end of, to whatever index from means. In fact, sorry, my bad. So it says starting from whatever index you provide here all the way to the end of the string. So this is same as saying, it's same as calling the prior method and saying from and then comma the length of the string. It's one and the same thing, but this is convenient. The next method we look at is index of. So let's say we want to search for a string within a string. So as an example, let's say there's an address, and if we want to find that the address is from Irvine City, you would look for word Irvine in the address, and if there's a word Irvine, then probably the address is from Irvine City, and you would do that using the index of, wherein you'll pass Irvine as a parameter, and it'll return you the index of where Irvine occurs for the first time in the address. If there's no Irvine in the address, it'll return a -1, which means the substring could not be found in the parameter could not be found in the string. Next is compare to. Compare to is used to compare two strings. Let's say you want to find all people with name John, then you would call compare to on everyone's name, and wherever you get if John same name, like, if you find a match, then this method is going to return you a 0. If but there are other uses of compare to. So what it says is, if there's a match, it's going to be 0. If there is If the given string, like the string that you're looking for, is smaller, then the result is greater than zero. If the string that you're looking for is bigger, then the value is less than zero. So we'll look at it through an example to get more clarity on it. But essentially, it compares to string character by character. Uh, the last method that we will look at as part of AP coursework is toString method. So every object in Java has a toString method, and it just returns the string form of this instance. So this is the Java object instance. So you can call toString on any Java object, and it will return you some value. So if every object has this method, so does a string object. But in string object, doing a string.toString will give you the same result as just using the string. So it doesn't add a lot of value, but it's good to know that every object has this method. And why do every object have this method? Is because every Java object by default inherits from a class called object class in Java, and that object class has toString method in it. So that's how all classes inherited. So we'll look at an example of that as well. So let's start with the
Oh, I just have one more question.
yes.
I'm a little like confused with like some of the point of the functions. Like for example, like the compared to, couldn't it should just do like if blank equals blank? Like it's
You
isn't that like
can
kind of the same and it's easier because you don't have to like remember all the names.
you can actually, but in that case, okay. So there is a difference between equality, which is double equal to. There's something called as equal to method. We'll also look at that, and there's difference between compare to. So compare to is you would like to know. Let's say if you want to arrange all the names in ascending or ascending alphabetical order, right? Let's say all names starting with A will come first, and definitely Z will come last. You would use compare to in that kind of a scenario more often, is because compare to will tell you whether it is not only when it is equal, but it's also going to tell you whether what you're comparing is greater or smaller, so you can make that decision of arrangement. But if you just go with double equal to, then it'll tell you whether it is equal or not. It won't give you any idea about whether the two strings are greater or equal to, I mean, greater or less than each other.
Oh yeah. So greater or less than is based on like alphabetical order.
Yes.
Okay.
Yeah. So compare to will compare two strings, each character at a time. So the moment it finds a mismatch in the characters, like let's say hello world, and you could try to compare that with hello Java, so it'll find, okay, it's matching all the way until hello in both cases, but at one place is H and like world, and the other place is Java. So there's a mismatch now, and it is going to tell you how much is a mismatch. So essentially, so J is smaller than W, so it's going to say that hello Java is smaller than hello world. Make sense?
Yeah.
Yeah, if you just use double equal to, it would just say, oh, it's not equal, but it won't tell you it's not equal by how much.
All right. Yeah. So you just do it for
Right?
basically the feature greater than or less than.
Yeah, for most cases, and it is used in sorting. It is you want to arrange things in ascending, descending orders. So that's when it comes very handy.
Okay.
And of course, you can also use it to compare two strings for equality. You know, so you can use it simply as double equal instead of doing double equal to. If compare to is not equal to zero, it means it's not equal, right? It's it's only when the result of this is zero, two strings are equal, else it is not equal. So you can kind of use it interchangeably.
Okay.
All right. Any more question before we proceed? All right. So we'll write a bunch of code today. So get ready for that, and it's all going to be very interesting. A lot of use cases of string in the real world. So let's start with the first method, which is length. So let's look at this hello Java. right? That's a string, and how many characters in there? There are 10 characters essentially. So let's write this program. All of you open your IntelliJ or your preferred way of writing code, and then let's write it together. So I'm going to. So I don't know what state of your project is right now, but whatever is inside the main method, you can delete it, and let's declare a string. Let's call it str. It's not a good name, but we'll just for the time being we'll just say str, and we'll do hello Java, right? So now we have a string object hello Java, and then we'll see how big. We'll find the length of the string object, and the way to do that is let's declare a variable integer length is equal to str dot get just length. We'll call the method length on it, and we'll print it out. So we'll do system dot out dot print
Wait,
line.
should I create a new project? I have the bug thing up open. The
Oh
bug
yeah.
creator.
Oh okay. Yeah. Close that project
Okay.
and and you can open the previous project that you had, or you can just create a new project.
Okay.
Yeah. But close the bug project. We'll come back to bug project later.
Okay.
Anyone else uh, having any questions about it or doubts about it?
Can you zoom in a little bit?
Okay. How about this? Perfect. So so everyone, when you have written this, go ahead and run the program. The way one of the easier way to do that is right next to on the left side where the line numbers are of the main method is a green arrow. Click on that and it says run hello string.main in my case. And the moment I run that, I get the length as 10. So do you all get the same result?
Yeah, I got the same thing.
Awesome. Let's wait for a few minutes for everyone to finish writing this. All right. So we all got result as 10. And then it should be 10, right? It's as expected. Hello world is actually 10 characters long. So this is so simple to use length to find the length of the string, which is essentially how many characters in the string. So let's move to the next method, or next program, I'll say, which is now we know that there are 10 characters in the hello Java string. So let's print out each character at a time, right? After this print line, let's do a system.out.println and character at index 1. So the way to find the character at a given index is call the method char at, and then index is 1. So we are asking, so we call a method on the string to return us index. So we now know it's 10 characters in the string. So let's copy this whole line, just paste it 10 times. Okay. Paste a few times and then change the index from 1 through 10, 1 to, don't forget to change it at both places. 3, 4, 4, 5, 5, and then this is 6, 6, 7, 7, 3 more to go, 8, 9, 10. All right. So we'll say 8. So, okay, give me character 8, and so will be 9, and then 10. So everyone, let me know when you all are here, and then run the program. Save your changes, run it, and see what the output is. Anyone want to share their output experience, or like what do you see in your output?
Mine says process finished with exit code 1. But before that, there's a bunch of red text.
Okay. Interesting.
Oh.
How about anyone else getting a different output?
At the very top, though, it says
Getting an error.
Yeah,
sorry.
mine at the top it says it spells it out, except it doesn't have the H.
yeah, me too.
It didn't start at
Okay.
0. And then it didn't even do 10. But and then it gives an error. So
Awesome.
Oh, okay.
So
I'm getting an error because it's out of range because it should start at 0, not 1.
yeah.
yes, exactly. So the idea is to kind of experience this error. Well, I got the error too. So why is the error? You guys got it absolutely right. I think you guys are loving string. That's good. So the output is with the error. H is missing. Like what happened to H? Where is H? And then we get an exception. So what happened here? Now, if you look at Hello Java, you look at this has 10. The length is 10. So it's not very intuitive. Why should index 10 be zero, like out of range? What it is saying is at index 10, there's nothing. So we are going beyond the length of string, but the length of string is 10. So we would expect to be working. And someone's mic is left on. All right, thank you. So anyhow, the point here was in Java string, the index of the string starts from 0. So instead of 1, it starts at 0. So when you do that, then the last character will be the length minus 1, which means even though the length is 10, the last character is at 9. And we do see ninth character being printed, which is A, which is the last character. So if you guys want to fix it, just paste a line above, like delete the last line and put a line on top of 1 and make index 0, and you will see Hello Java being printed just fine. So the point here is, whatever the length of string is, the last character is at length minus 1 index, right? And this is important to keep in mind, is because if you remember the methods that we looked at, all the substring and all that, it requires indexes, right? So we need to give them those methods right indexes, else we'll run into such problems of index out of bound exceptions. All right, any questions on this? All right, moving on. So we talk about substring, and now we are looking at substring. So let's see how substrings work. As we discussed, substring is a way to get a part of a given string. So let's write a code together. We can delete all this if you want, or you can just comment it out. It doesn't matter. Essentially, we're not going to look at it. So I'm going to just delete it, right? And I'm going to delete all of that too. Let's declare a string. Let's call it some quote. Always. So all quotes are in double quotes. So we'll put an escape character and say, okay, this is going to be a double quoted text. What the code says is, code is like humor. When you have to train it, add, right? Such a profound quote here, and these are the thoughts of Holy House, right? And then that's how we declare our string. In some cases, you will realize that your string is way too big to fit in one screen. So what you can do is, wherever you feel it convenient, you can just hit enter, a new line, and then make sure that there's a plus sign, so that concatenates all your strings together into one eventually. But in this way, you can break it down and make it look pretty in the source code at least. So that's our code, and now we are going to experiment with some substring operations. So before we do that, let's print our code out. System.out.println, and it'll print our code. Save it, run it, and there it is. It does print out our code, and everything is in double quotes. So we are good here. Now let's try to print a part of this string. So a print line will easily print the whole thing, but the idea here is to print a small portion of it. So we'll do system.out and print, and substring is exactly going to help us do that, right? So there are two substring methods, if you all remember. We'll try both of them here. So the first way would be, you have a quote string object. In there, you put a dot and then call the substring method. So even here, you can see there are like two substrings. So let's do the first one, which has a beginning index and the end index. So starting from index 0, which is in the given string object, let's print up to 8th character, right? And see what comes out. Similarly, we'll try out a different substring method and see what that prints for us. The second trial. So what is that going to be? A quote dot substring, and so if you look at methods, the second method takes only one parameter, which is just a beginning index. So in this case, let's print from index number 15. It's a random number. You can choose any number you want. Save it and run the program. So did the program run for everyone?
Yeah.
Okay. Any surprises in the output?
Yeah. Well, on the second one, I was a little surprised because it basically just ran from the 15th to the very end.
Yes. Okay.
I expected it to run like from the beginning to 15, or I expected it to run from the beginning to 15, but
Yeah, no. So it's from the start index, which is you give it a number, and then from there it'll run all the way to the end.
okay.
Yeah. If everyone is here and got similar output, Then let's look at our output and see if we can find something which is not exactly what we wanted. So in the first case, we asked the substring to return us a part of string, part of quote starting from index 0 to index 8, right? And then we if you count the output number 1, it is only till index 7. So why is that? So if you look at this, double quote is index 0, C is index 1, O is index 2, D is index. Wait a minute. Wait. Oh, so double quote is index 0, C is 1, O is 2, D is 3, E is 4. Then there's a white space which is 5, I is 6, and S is 7. So, so why is that? Well, so if no guesses, as I said, the Java string is. Oh, all right. So the reason why that is because Java string is zero index based. So if you say give me 8 characters from 0, then it's going to give you as it's so it'll give you 8 characters, but as starting from 0, it's actually character number 1. So that's why we get one less. All right. So can everyone try this on their computer and try to run it? Just add another line and do a case number 3, and then do a code dot substring 0 comma code dot length. Let's do it together just in case. I'm going to copy the previous line. I'm going to paste it, and then I'll say I'll do it.
Oh, it just printed the entire thing.
Yeah, that's what is expected. It's going to print the entire thing, and yeah.
Don't we have to length -1 though? Because like it's gonna be like past it.
So essentially, the substring takes care of that. Because code.length, we know it's going to return 10. So what we're saying is starting from 0, go to the 10th character. But we know that there are only, like, if you look at the Java string out here as an example, you'll see that there's no 10th character.
Yeah.
So the substring is going to subtract 1 for you. That's why whatever number from is the first and the 2 is the second parameter. So from is always inclusive, 2 is exclusive, which means it's going to do only from 0 to 8 minus 1 or 0 to quote length minus 1.
Okay.
Yeah. So substring, what it does is the first parameter is inclusive and the second parameter is exclusive.
Okay.
It excludes it. All right. All right. So the next is we will try to understand index of. So we'll keep the code as is, or we can, let's just comment it out. Let's comment out these 3 use cases that we just wrote, and then let's. So index of is it's kind of a search operation. So given a string, if you want to find something in the string, then you would use something as index of method, which says at what index is the first occurrence of the string. So let's say in the given quote, if you want to find where humor is in the string, then what index of is going to return is starting from 0, what index is h, like humor occurs in the string, which means at what place does h occur in the string of the humor word. Right. So let's experiment that. So we'll use the same quote, and the first thing we're going to do is print the quote out, and then next is we'll find different things in the string. So system.out.println, and then let's find if the string contains a quote. Let's save it. Let's run it. My bad, I didn't complete the sentence here. So see, that's why your output should be a little verbose. Oftentimes, is it helps explain what we are running. So the first experiment is to find if there's a quote in the string. So the way we do that is quote dot index of. We're asking the string object where in the quote string is a double quote, right? So if we run that, it's at index 0. We know that it's the first thing in our quote string, and it says yes. It says it does say it's at index 0, the first thing in the string. Now let's use this and try to find a few other things in the string. So this is use case 2 now, and here we're going to ask the string object where is humor in the string, and let's run it. And humor is at character 14. So if you count from double quote all the way, you will realize the h of the humor starts at character 14. Find a few other things in there. Then you have to, right? So let's find a bigger string in a given string. And it's not a word; it's kind of a sentence by itself. What is the output? Output is 21, which means, let's mark it 3, which means in the given quote, where you have to, the W of the where starts at index 21, right? So when that's the case, let's do an experiment, and let's create a use case number 4 for where. Oh, sorry, when. And then when we run it, the result for that is also 21. So what it is doing is when it finds a given string that we are looking for, it is going to return the index of first character that matches of the entire match, right? So when you look for when you have to in the given code, it starts matching at index 21. Similarly, when you search for the word when, even there's a match in the string and it starts at character 21, right? Okay. Now let's look at another example. Let's paste it. This is our number 5, and let's look for Corey house, right? And then let's also look for something which is not there in the string at all, right? So let's look for maybe Java AP. That's not there in the string, and we'll see what output we get. So everyone save this and run your program, and tell me what output you get for 5 and 6, and we can explain why you get that output.
I got. Wait, can I say my output?
Yeah.
Okay. For number 5, I got 63.
Okay.
And for number 6, I got -1.
Okay. Is your house uppercase or lowercase?
My Corey house.
Yeah.
Oh, sorry, mine's uppercase.
Yeah.
Oh
Make
shoot,
it lowercase.
it'll probably give -1 then.
Okay.
Let me see. I'm running it. Yeah, they're both -1 now.
Okay. Anyone getting a different result? We all should get a -1 for the last two. But in my case, when I was making this slide, I didn't have the when search, so my indexes are off by 1. But essentially, the idea here is the last two should return a -1. Why should a Corey house return a -1? The Corey house word is in the string. So what happened there?
Yeah,
Can
the
you guess
H
it?
isn't capital because Java's case
Okay.
sensitive.
Yeah, but then Corey is a match, right?
Yeah, but the entire string has to be match.
Exactly. You got it right. When we call index of, the entire string has to match for this method to return any result. Now, what we see here is Corey house did match half of it almost. In fact, exactly half. But we get a -1 result. So we'll never know how much portion of the string matched the quote. We just know that it didn't match, right? So sometimes we want to know more, like how it did not match is fine, but by how much? So index of it doesn't tell us that. It just says whether it matched or not, right? So let's see if there's a way around and find out by how much did it not match. And luckily, Java string provides compare to method, and that's what compare to is going to give is tell us by how much is a mismatch. So let's write a program. Very simple. I'm going to delete all of this to make some space, but you can go ahead and comment out your code to keep it as a reference. Then delete that. Let's declare a string variable. Name it as message, and the message is loud and clear, which is hello with exclamation mark. Why not? Let's be surprised when we meet. So let's first print the message. Line and message. Save your program, run it, and you'll see it prints hello. Right? Nice. So we are good here. Now let's try to experiment with compare to. So now we know the drawback of index of is it is going to just return us a -1 without telling us how much it didn't match. So we don't know how much did match. We just know, oh, well, it couldn't find anything. So let's see compare to can help us here or not. System. So let's run few experiments. System.out.println, and case number 1. Plus we'll do a message dot compare to. Now let's compare this with the hello exclamation, right? So let's run it. So we're comparing hello with hello. So it says 0, which means it's an exact match. That's what we expected. So compare to works, at least for exact match. Let's copy this. This time we'll paste these and write few compare to before we run all of them. So in the next case, let's delete the exclamation. And we know that if this was, well, index of would have found this match as well. But anyways, so let's delete the exclamation. And what we expect is compare to will tell us how much did hello match with the message hello and exclamation. So it's gonna actually give us the actual difference in the two. Experiment number 3 is let's delete the uppercase h and replace that with the lowercase h, right? Let's try another one and a completely random string here. Let's call it zoo. It has nothing to do with hello. We just put it there. Uh, I forgot to update the index here. For fifth index is let's do Java. Okay. Right. So we know two strings. They are not going to match hello at all, right? So once you have this, go ahead and run it, and let's look at the output together, right? Take a few minutes. I hope you all have your code running by now.
Sorry, I came late. What have we done so far? I joined like 5 minutes ago.
We looked at, we revised what we did previously, and then we looked at, we started looking at string methods, and we did index of so far, and now we are at compare to. Well, we also did substring. So we looked at index of and substring to methods on string object, and now we're looking at compare to.
Okay, so what should I have so far? I mean, should I just wait then?
No, you can at least write what you see on the screen right now in your IntelliJ,
Mm-hmm.
and we can start from here. And Kumar can share the video with you, uh, uh, and then you can kind of just go over those two methods that you missed out on.
Okay.
Or maybe after the session is over, I can fill you in quickly.
Okay. Mm-hmm.
Okay. So for everyone else, were you able to run the program? I hope everyone has similar output.
Yeah, I have the same thing.
Great. So we know the first output must be zero, should be zero because it's an exact match. Hello versus hello explanation, right? So what about number two? Why is it one? Any guesses? Why would compare to return a one when we match hello exclamation versus just a hello? Because it is telling us both strings are different by one character, which is one has exclamation, the other one doesn't have it. Okay, so that explains it. But can you all explain the remaining three, the negative numbers in the output? Anyone wants to take a guess? Why would a lowercase hello and exclamation return a -32? Uh, a string right above it, it had just one missing exclamation, is returning a one, but a string below it, which has just one character of, one is uppercase and is lowercase, everything else is exactly same. It returns a -32. Or a zoo, and we get a -18. Or a Java returns a -2. Any guesses? All right. So it's very subtle, actually. So look at the hello exclamation. The first character is H. So compared to stops the moment it finds one mismatch, right? So it looks at first character H in hello, and then it looks at, let's look at the case number 5. It looks at the first character J of Java, and it says, is there a match between J and H? There's no match. But how much is the difference? So in English alphabet, H will come first, uh, and J is like two characters from H, right? So J is you're comparing a lower character, order character by higher character, the higher
Huh?
order character. It's a negative two. Yes.
What happened?
Um, Nothing. I was just explaining why case number five is a negative two.
Oh, sorry. I wasn't talking. I got distracted.
Oh,
My bad.
yeah, no problem. So the reason here is because H in alphabet comes earlier and J comes later by two characters. So comparative is telling us the first mismatch it found, it is a mismatch of two. Uh, and as J is greater than H, it's like subtracting J from H. So we get a negative result. Now, if that explains it, can anyone take a guess why Zoo is a negative 18?
Because it's Z compared to H.
Yeah, that's right. So Z is 18 characters away from H. Um, how about number three? Why is it negative 32?
I think it might be because they do all of the uppercase first and then lowercase. I don't know.
You are right. And where do they have this rule? Any guesses on that?
No.
Okay, but you are absolutely right. Lowercase h is later in the list of characters than uppercase h. So the difference between the two is 32 character gap. So between uppercase and lowercase h, there are 32 characters in between them. In a long time ago, we actually looked at that list of those list of characters. It's called the ASCII character. Um, you can look at you can do an internet search and then you can easily find out. So as an example here, you can see that how the uppercase h is at number 7. Well, it's actually not number 7, but it's easy to understand this way, whereas the lowercase h is at 33, right? So that if you take the difference, that's what we got. All right. So let's move on to the next next method, toString. In fact, I don't have the person class anymore. Do you all have it in your computer yet? If not, we can just quickly write it again.
I deleted it.
Deleted it. Okay, let's write it again. We'll not write it as elaborate as we did earlier, but the way to do that is in your source directory, right click.
Sorry. Could I get some help really quick with my Java?
Yes.
I don't know what happened.
Okay.
Can I present really quick?
Yeah.
So I have this old thing. So I can't make a new one. I don't know why. What would I
Give me
have to
one
do
second.
here?
So, okay, do a cancel. Okay, so go to your project, or you can just go to file, do a new project, and then Java is fine. Go to next, and then just
Switch.
go to next again. Yeah, and yeah, give it a name. See if that's the right location you want to have the project in, which is in your IntelliJ.
What should I call it?
So I've named it AP ComSci 2020. That's a good name.
Oh, this one.
Yeah,
Okay.
just don't put space in the name. Yeah. Do a yeah this window. So it'll close your current project and it'll open the new one for you.
Yeah, and then where do I go from here? That's
So
what I.
expand the arrow. you will see the source directory there. So right click and do a new Java class. So we have hello string. So have H uppercase and S uppercase. Hello string, one word. Yeah, enter. Okay. So inside your hello string, write public static void main, as you can see on the screen. And for everyone else, go ahead and delete contents of your main class and just keep hello as one string in it. Right. So Parashar, you want to print it out and see if it runs for you?
Yeah. Let me just write it down.
Well, a few things missing. Wait, slow down. So in your main, after string and the square brackets, there's a space. So I'm missing the space between square bracket and arg.
Here.
Next to it, there's
Oh,
a
space.
yeah, there's a space there, and then hit enter, and then yeah. Double quotes. All right.
And that's it, or I'll just print it.
Yeah, just put system.out.println and it should work. Put message in there. Okay, and then there's a green arrow next to the main method. If you press on that, it'll just run it for you from right here.
Okay.
No, the one below it should have been better, but that's fine. Probably it'll run it.
Yeah.
Okay, fine. So let's resume. Okay, we'll quickly write a person class. So everyone click on the source directory, do a new Java class, and let's call it person, right? And we won't put much.
I already have a class called person.
Okay, then you're golden. You don't have to do all this. But for everyone who don't have it, quickly write a
Oh,
class
but it already has a
person.
bunch of stuff in it. Should I delete that?
No, keep it.
Okay.
Yeah. I accidentally deleted mine, so now I'll not we'll not write it as elaborate as you have it, but we'll just briefly have few things in it,
Okay.
like string.
I change mine too.
No, don't change it. If you already have it in the current project, then don't change it. If you don't have it in the current project, then create one.
So do I create another class then, or?
Yeah. So under source, just right click and do a new class, and then name it person.
Yep. Yeah, I got it now.
Yeah. So let's just have few things in the person object. Let's say day, day, month, and that's it, right? For the time being, let's just keep three things, make it simple, and let's have a public constructor. So it's a public person. It takes parameters, string name, in day, in month, and then this dot name is whatever the parameter is. This dot day is whatever the parameter is, and this dot month is equal to month, right? we have that. Now, so in this person method, we have just one constructor, right? For people who have the person class, you may have few more methods like get date and all that. Um, the point here is to see how many methods do we. If you have methods in it, just keep a look at those methods and get familiarized. But people who have just freshly written it, we don't have any methods here. We just have a constructor, right? So and then make all our member variables private, so we can't access it from outside. The only way to do that is to through constructor as of now. Let's come back to our hello string class. Inside the main, we have this object called message, which is hello. And let's create a person object. Person, let's call the person Joe is equal to new person, and then we'll pass parameters. So we'll call it as Joe, and we'll put today's day and month, which is 17 is a day, and month is June. There. So we created a Joe object. Now, what we are trying to do here is we are trying to understand the toString method that string provides. In fact, we learned that it is not only string that provides it; it is provided by all Java objects. So let's print few things. System.out.println. Let's print the message first. System.out.println. As it is toString method, let's see if string has it or not. So this is our experiment use case number 1, and we'll print message.toString and see what this method returns us. Similarly, system.out.println use case 2 is Joe.toString. So Joe has toString in it, but if you go to the person object, there's no toString. There's no method called toString, right? But when you create an object, you get a toString method on it. So this is because this toString is a part of the Java object, which is a super class of all objects in the whole Java world. So no matter what object you create, it is a child of object class, and that has toString. So automatically all objects get toString method. Now you can also look at what all other things are there in this object class, and things like clone and other things which we're not going to use, but good to get familiarized with. Anyhow, coming back, so that explains why Joe has this method toString even though when we didn't declare it. So when you are here, save it, run it. So everyone got this output? Oh well, default constructor called, ignore that line. But apart from that, you all should get the same output.
Sorry, what are the ones in the twos and the like all the numbers?
Oh, those are just to say that's experiment 1 or use case 1 and the use case 2. So first thing we are trying is message.string. So in the output,
Oh, okay.
you can kind of distinguish, identify what a step printed what.
Okay.
Yeah, so step number 1 is message.toString, and step number 2 is Joe.toString. It has nothing to do with anything else. So everyone got a similar output?
I got different numbers, but
Okay. How about others? All right. So we learned that the person class does not have a method named toString, and still we could call it. Where did this output come from?
Yeah, the same thing happened to me. I got just different numbers.
Yeah. Okay. That's great. So the question is, where did this come from? And the question is, what can we do to print meaningful output?
Oh
So
wait,
this
actually,
means
sorry
nothing.
to interrupt. There is one difference with mine. I
Okay.
don't have the AP at the beginning, like the AP dot. Mine's just person at and then a number.
Yeah, same with me.
Yeah. Okay. Yeah, not a problem. In fact, the project that I printed this from, I created a package called AP.
Oh,
So
okay.
yeah. So it kind of prints ap.person. In fact, let's do that. Let's right click on the source and go to new, and then there's a package. You all see it? Click on that and just call it AP. Give it a name. Oh, don't click it. Create a new package. AP lowercase. The package names are lowercase. And then let's move the person class. Just click, drag, and drop it into AP. It'll tell you, oh yeah, refactor it. Click on refactor, and now your person object, a class, is inside AP, right? And then once that's the case, go back to your hello string and then run the main program. So now do you all get AP dot?
Yeah, I do.
Great. So essentially it says that the person class is inside AP package. And this is what package is. Essentially, we create logical grouping. In this case, the name doesn't make any logical sense, but that's how easy it is. So the question is, we did not create toString. We're just using something, and then we get printed some random output as if we have no control on it. So can we do better? The answer is yes, we can do better. And as I said, we inherit this toString from the object class. So we'll override the definition. So we'll say don't print default, print what we want to print. So to do that, we can do a public, and this is toString. Well, and so this method is going to return a string, toString, and then return. Let's say we return the name, and then date of birth as day, month. Okay. So this will just work fine, but it is a Java convention that when you redefine something, then you typically write override on top of it to tell Java that this is not a method that originates within person. This is something that the person is overriding from its parent. So let's say if you end up doing a string 1, then Java will tell you there's a problem, right? But if you don't have that override, Java will say, oh, well, it's not a problem. That's how probably you want your method name to be. So to make sure that whatever you override is the right method, we typically write this override annotation. It's called annotation on top of the method. So now when we have that, let's go back to hello string and then run the program and see what the output is. You all should get Joe date of birth 17/6. Right?
Oh yeah, that's what I got.
I'm getting errors.
What error do you get?
Well, it's on my, for some reason, it's on my name, day, and month variables.
Okay, do you want to share the screen real quick?
Okay. Wait, hold on, I have an idea.
So,
But never mind, it's working now. Never mind.
okay, perfect.
Except my date is different, but that shouldn't
Yeah, that's
matter.
fine. Yeah, you have the real deal. Yeah. If we had the same, if I had the same class and everyone had the same class, then we would have got the same output. But the point here is now our output is consistent. It's something that we control, right? So similar to this, in string class, they have a method called toString, and it essentially prints the same string back. So as the message is hello, the first line prints hello as like message as is. The second line, which is calling toString, makes no difference in this case. So we don't see the difference in string object, but we do see difference in other objects, right? So toString is a very powerful way to summarize your object, whatever the content of that is. All right. So with this newly learned knowledge, let's learn a very tricky aspect of the string class, right? So to do that, it's going to be a little longer program, but that's what you're here for, right? So let's write a program, and you guys can follow what I'm doing. So delete everything. Oh, comment out everything inside your main, and then let's start from scratch. Let's declare a variable of type string called str0. Let's call it begin. You all can see my screen, right? Okay, let's create another string, and then see how the string 0 is being created using literal. There's no new here, just in double quotes. The next string is Java. Let's create another string called str. Let's say string 2 is Java again, and then a string string str3 is, let's create it in using a new operator. So that is new string, and let's call it Java. String str4 is another string using new, and let's also call this as Java. String str5 is equal to str2. So we're saying string 5 is whatever string 2 is, which is Java, at line number 6. And then we do a string str6 is equal to str3. So we're saying string 6 is what string 3 is. Right. So what we did so far is we have created 6 strings, 0 through 6, out of which the first 3 are using literals, which is we are not using any new. We are just using double quote string to create object. Out of those 3, the last 2, string 1 and 2, are exact same string Java, whereas string 3 and 4 are created using new operator, and they also happen to have the same string Java in them. So now essentially we have 4 strings which have Java in them. Then we create 2 additional strings, string number 5, which is same as string 2, and string number 6, which is same as string 3. String 2 is created using literal, string 3 is new, and which means now we have 6 string objects, and they're all Java, right? So what we're going to do here is, in string, there's a method called equals. So we're going to learn more about what equals does, right? So to find if 2 things are equal or not, there's a logical operation in Java. It's called double equal to, right? Which means if you want to say that 5 is equal to 5, then you would say 5 is equal to 5, right? Because 1 equal is assignment. So double equal means comparison. So similarly, in string, you can compare 2 strings by using double equal to sign, right? So when you can do that, then why did string provide a equals method as part of its class? And we'll try to learn that. So to do that, let's print out a few things: system.out.println, and experiment 1 is we'll do equals. Well, experiment 1 is using equals. We'll call the equals method on string. We'll compare string 1 str1 with string 2 equals str2. So we see that str1 is Java, string 2 is Java. So equals. So equals is a method that string. You call it on string, and it will tell you if the strings are equal or not. Okay? So it's a Boolean. The return type of equals is Boolean. Either it will say true or false. Either it is equal, which is true. If it is not equal, it will say false. So we expect str1 and str2 to be equals because they have exactly same string in it, Java. So you can copy this line so that we don't need to repeat, write the same thing again and again. Experiment number 2 is using the double equal to, which is which is logical operation. So which means it also returns a Boolean. And don't forget to put these in bracket, right? You know why? Because else the whole thing will get converted into a string for us. So essentially, what we're doing here is we're saying, are these two strings equal? Which sounds similar to the first, but we'll see what the difference is. The next experiment is number 3. Is we are going to do equals again, but this time we're going to do string 3, which is using the new operator. Is it equal to string 4, which is using string operator, a new operator as well? So we're saying these two objects we created using new operator, are they equal? And then similarly, experiment 4 is double equal to, is string 3 double equal to string 4. And let's let's copy both lines, because we're going to just play around with equals and double equal to. So next experiment is string 1 equal to string 4? String 1 is using literal, string 4 is new. Similarly, is string 1 equal to 4? Then don't forget to update the index here, 5 and 6, so that we know exactly what line is printing what. Step number 7 is let's compare string 5, which is, if you look at the declaration, string 5 is string 2. So we say, is string 5 equal to string 2? And then similarly here, we're going to say 5 equal to string 2. It's a way trying to print out different combinations of things here to understand double equal to and single equal to behavior. This is 7, this is 8, this is 9, this is going to be 10. So we have 10 lines of code here. And the last two is, we'll compare string 6 with string 3. Is string 6 equal to string 3? So save your program once you have written all this. All of you ready? When you are, go ahead and run the program. So do you all get these bunch of trues and falses?
Yeah.
Okay. So first thing is to note the equals method returns a boolean because we're getting true or false, right? Similarly, double equal to also returns boolean because we are again getting true or false. So they're just telling us whether objects are equal or not. So let's investigate what output have we got and why did we get this output. All right, so we all got this output here, which is a bunch of true and falses. So let's look at the first output. Why is string 1 equal to string 2? Is because they both are Java, right? And that's why equal returns true and double equal to also returns true. But let's look at the next two outputs, which is string 3 and string 4. String 3 is Java, string 4 is Java as well. So when the first two steps return both true, why did the second step return, like step number 4, return a false? Any guesses?
Because like you're comparing the literal to the other type.
In fact, line number 3 and 4 are both new objects. They are not literals.
Well then
The first,
probably when you actually like use it as like a method, you have to use the equals method because if you do like the literal, just I don't know, just doesn't work.
okay. Anyone else wants to guess? But you're right. Any more guesses? So the point to be noted here is which one of the two outputs is right output. And so if you look at number 3, step number 3 and 4, which one would you expect? So 3 and 4 both are str3 and str4 are both new Java type objects. So we expect them to be exactly same, which means line number 3 is returning us the right value, right? So line number 3 is str3 dot equals str4. So that gives us right result, but str3 double equal to str4 doesn't give us right result at all. Whereas the first two steps you see, where str1 double equal to str2, it is actually giving us right result. It is giving us true, which we really wanted. So there is something going on here. Let's see if we can understand what's going on by looking at the next two outputs. Now, the next two output, what it is doing is it's comparing string 1 with string 4, and both are Java. So the str1 dot equals str4 returns true, whereas double equal to returns false. Now, in step number 4, what we compared is two objects created using new method, and the double equal to returns false. In step number 2, we compared two objects created using literals, and the double equal to returns true. Whereas in this step number 6, we create one object using literal and the other object using a new operator, and the double equal to returns false, whereas the equals is returning the right result. And as we look at other cases, we'll see that equals is always returning us right result. Um, Same for step number 7 and 8. 7 is saying is string 5 equal to string 2. Well, at line number 12, we did say string 5 is string 2, so makes sense that is true for both scenarios. And same for if you look at step number 27, 28, step number 9 and 10, sorry. What it is comparing is string 6 with string 3 using equals and double equal to, and both are true. So we see that double equal to returns valid results sometimes, and returns unexpected results often, like other times, whereas equals is returning the right result all the time. So what's going on? Is double equal to wrong? Is it a bug? Well, let's understand it. So this what is happening is because how Java creates objects when you declare it as a new or when you declare it as a literal. So in the very beginning of our session today, we had a question: what is the difference between creating a new object, new string, versus using literals? And this is the exact difference, and it is very subtle to understand. Um, so what's going on is when you run a program, then the computer it reserves a memory piece of memory in the computer for the program to run. It's called the heap, right? So within the heap, all string objects are created in heap. So within the heap, what Java does is it reserves a small area of the memory, heap memory, used for string pools. So every time you use a literal to create a string, Java is going to take that and put it in the string pool, right? So when you say begin, it's using literal. So inside the heap, this object is created in the string pool. When we create a Java, which is str1, that's also in the string pool. Now, when we create the next object, where will that be? That's literal too. So we expect it to be in the string pool, but what Java does is when it looks at literal creation of strings, first it will look for what all are there in the pool before it creates a new one. So it'll search for, is Java already there? It finds yes, Java is already there in the pool, so it won't create a new object. It'll just point str2 to the same Java object as str1 is. So even though we create two objects at line number 8 and 9, inside of Java, those are only one object. They're just pointing to the same memory location. Why did Java do that? Java does this to optimize because strings take a lot of space. These are just a few characters wide strings, but strings can be very large, and each character is two bytes. So your string can easily eat a lot of space. So it's an optimization that Java does. Is if you already have a string, it won't create a new one. It'll just point the object to the same reference in memory. But when you use a new operator, Java doesn't create that string in the string constant pool anymore. It creates a new object in the heap. It can be anywhere in the heap. So str3 points to Java, and when you create str4, well, even though it is Java, as a new operator is used, Java doesn't go and search for it in the entire heap. It'll just create a new one for you. So str4 is a different object. str5 and str6 are just pointing to the references. So so what difference does it make? The difference it makes is when we use double equal to compare two string objects, what Java is comparing is not comparing the string, it is comparing the memory location of the object. Are both objects located in the same memory location or not? So that's why when you do line 16, str1 equal to str2, it'll return true, is because both str1 and 2 are pointing to the same object, string object in the pool here. That's why it returns true. But when you look at line number 19, str3 is double equal to str4. Well, these are two different Java objects. They are pointing to two different memory locations. So it is going to return a false. None of these two don't match. So essentially, that's a problem, is how do you compare if two strings match or not in Java? Because the moment you use double equal to, which is the very commonly used way of comparison in Java, it returns a wrong result because it's comparing the memory location rather than the content of it. So Java added a method called equals. And when you call the equals, then instead of looking at the memory location, it looks at the strings by character and will tell you whether the string matches or not. So there are other ways to find it, if the strings match or not. Then why use equals? Because equals is more optimal in searching, so it's going to run faster. Any questions? All right. So, well, we don't have to do this. We already did our part of experiment to learn this. Now, the fun part is fun quiz. All right. So now I'm going to pick people at random, and it's time for you to shine, answer the questions. But it's fun question. We're here to learn, so don't worry about if you don't get it right. The question is, what is the value of len after following code executes? String 1 is QWERTY, and int len is str1 dot index of e. So Grace, do you want to guess what the output will be?
Is it going to be negative D?
Why will it be D?
Sorry, 1 second. I'm checking my notes. I'm not really sure.
Okay. All right, not a problem. Parashar, do you want to guess what the output of this will be?
My only guess is 3 because I mean, I don't think I was here for this, but in len, integer len, it's the number of, so then QWERTY is the so str1. So then the
Okay.
third, E is the third letter of the string, I guess. That's the way that I thought of it.
Okay. So we have one answer as -1, one answer as 3. Zain, do you have a different answer?
Yeah, I would say 2 because it
You
starts
said
at
2.
0.
Okay, yeah, you're right. So 2 is the right answer here, and the reason why it is right is because in Java, string characters they start at index 0. So Q is actually index 0. That way, W is index 1 and E is indexed 2. So if you run this program, your len will be 2.
I have a question just to confirm. So basically, you would count from 0, so Q would be 0, and then so on, and that's why
Yes.
the answer is 2. Okay.
Correct. And index of what it does is it looks for the first occurrence of the whatever string you give it. So it will look for the first occurrence of E. So if there were like 1 million occurrences beyond it, it doesn't matter. It will just always give you the first occurrence, and that is after at index 2 because Java index starts from 0. All right. Let's look at the next question. What is the value of len after following code executes? String 1 is student, and we do a string dot length. So what will be the output here? So, Hallie, do you want to guess the output?
I think it'll be -1
Why will that be -1?
because it's not, because there's nothing there.
It's well. Look at the method. It's length. It's not index of.
Oh, yeah, you're right. Then I think it'll be, hold on, 7.
7. Yeah, you're right. 7 is the right answer here. So the length gives total number of characters in a string, and
Wait, sorry. So in this case, it doesn't do the 0, 1, 2, 3. It starts at 1.
yeah. So length is count of characters, but index is so the reason why. So this is one confusing part of a string. That's why I put these two questions here intentionally. So when you do index of, string is actually array of characters. We have not got to array yet. We'll go in later courses. We'll go to that. But essentially, arrays in Java and even in C, C++, they start with index 0. So that's why when you do index of, it is going to just tell you at what index in the array is that alphabet or string match happening. Whereas the length is going to tell you how many elements are there in the array. You know what I'm saying? The difference?
Yeah. Yeah.
All All right. Good going, guys. The next question is, what is the value of str2 after following code executes? String 1 is baby, and the string two is string 1 dot substring 1 comma 3. So, Edward, do you want to answer this question?
I think it's ABY.
ABY. And why is that?
Yeah, ABY. Because A is 1 and Y is 2.
Okay. Anyone has a different opinion on this? Nate, do you think do you have any different answer for this question?
Oh yeah, I think it's ABY too, actually.
ABY. Okay. Anyone with any other choices here? So we have two answers so far, and pick is C, ABY. Anyone else has a different pick? Open question. Well, I think
Maybe it's just AB. I just checked. It's
okay.
maybe it's
All right.
for the number of like 2.
Yeah. So the answer is AB is because in substring it actually works on the index. As we it's kind of, we are saying starting at index 1. So in this case, the first B is at index 0, A is at index 1. So it'll print A, and then all the way to index 3, which is Y. But then in substring, the 2 parameter, which is the last parameter, is exclusive. It only does 3 minus 1. So starting from 1, it'll print everything until 2. So it'll print AB. In substring, the second parameter is exclusive. It's not going to include that index, but everything before that. That's why when you do 0, 2 string, it's going to print the whole string, because anyhow, so there's a difference. Keep this in mind. In substring, the second parameter is whatever index minus 1. The next is, what is the value of string 2 after following code executes? String 1 is student. String 2 is string 1 dot substring 3. So, Gavin, do you want to guess the answer? Are you on mute? Do you have Sam today? Sam, do you want to guess the answer? I'm not able to see the list of.
Yeah, I will guess the answer.
Yes, okay.
Is it B?
Is DENT? Dent?
Yeah.
And why is that?
Because that's the right answer. I don't really have reasoning.
Okay, so that's the right answer for sure. The reason is because the substring just takes one parameter, and that is the from parameter. So it is going to include that, which is starting from character index 3, which is S is 0, T is 1, U is 2, D is 3, starting from there all the way to the end of the string, print everything. So it's going to return D, E, and T as the output. So when would we use something like this is when we want to get everything once we get a match. So we say, okay, the moment you find let's say if you want to find a city and zip code in an address, you'll say substring Irvine. The moment you find Irvine, give me Irvine and the pin code following the address, right? So you want to print all the way to the end, no matter where you find the match. All right, next question. What is the value of string 2 after following code executes? String 1 is student, string 2 is string 1 dot substring, 0 comma string 1 dot length. I think we did this example. It's a simple one. Anyone just unmute yourself and answer it if you have a strong hunch about what's the right answer here.
Student.
That's right. So essentially, str1.length will get replaced by the length of the string, which is in this case 7. So it's going to be 0 through 7, and as substring, the second parameter is exclusive. It's going to print everything from character 0 to character 6, which is the whole student word here. The next question, what is the value of string 2 after following code executes? String 1 is student, string 2 is string 1 substring, and then string 1 dot length. Open question, unmute yourself and jump in.
I'm not really very sure on this one, but I feel like it would be A.
Yeah, I think it would be A too.
A2.
Because there's no starting.
Yeah.
Okay. You're right. So what it is saying is, give me everything starting at the length of the string, which is nothing essentially. So length of the string is the end of the string. So give me starting, whatever is string after the end. So which is nothing. So it gives you an empty string. Next quiz. What is the value of answer after following code executes? String 1 is her, string 2 is him. The answer is string 1 compares string 2. Open question, unmute yourself. Is the answer positive? Is the answer 0 or negative?
Wait, sorry, what is this trying to compare?
So string 1 is her, string 2 is him, and then it is comparing if string 1 compared to string 2. So it's using the compare to method. So what will be the result of compare
I
to?
think it would be negative.
Okay. It's comparing her with him.
Yeah.
And why will it be negative?
Because her comes before him, so it's less than him.
Okay. And how much would be the negative result? It'll be less than 0, but how much? Less than...
Oh. I have to count it out.
You're right. Essentially, the reason why...
4 or less.
4 less, negative 4. Yeah, that's because when it will start comparing, it'll find both has H. It's a match. The next is one has E and one has I. So which one is comparing E against I? So it's going to do E minus I, and E in the alphabet, I comes E, F, G, H. So I comes 4 characters later than E, so it's going to be negative 4. All right, next, what is the value of answer after following code executes? String 1 is hen, and string 1 is hen with uppercase H. So when you do answer, string 1 compares string 2, what will be the result? Will it be positive, 0, or negative? So
Would it be negative again?
Will it be negative again? And why will that be?
Because I guess I don't know, maybe the lowercase is like not as, I mean, it's less than an uppercase letter.
You're
Isn't it?
close now.
Because the lowercase h came first.
Yeah, well, so this is going to be positive actually, but you guys were right. The reason why it is positive is because in the ASCII character table, the uppercase H comes first and then the lowercase h. So when the comparator starts comparing string 1, which is it takes the lowercase h, compares it with uppercase h, and it says, oh, there's a mismatch, and the mismatch is the lowercase h is later in the ASCII table. So bigger number minus a smaller number. So it's going to be a positive result. All right. few more questions before we conclude our session today. The fun ones for sure. What is the value of answer after following code executes? String 1 is hen, string 2 is den, and when we compare these two. Well, now I think we should understand what's going on here.
Would it be B,
B, a -5.
like -5?
Why will that be?
Sorry, could you please repeat that? It cut out.
Why do you think it'll be B?
Would it be because I counted backwards, so I went D, A, B, C, D, E, F, G, H, and it's going back 5 letters, if that makes sense.
You're right. But the intuition here is string 1 is H. It starts with H, which is a bigger number. Right? It comes later in the alphabet, and then from there we subtract D, which is earlier than H. So, which means from a bigger number we are subtracting a smaller number. So the result will be positive in this case.
Okay.
Right? So when you write A through Z, then you'll see that D comes first and then comes H. So when you compare H with D, you'll see D is like prior to H. All right. Next question. What is the value of answer after following code executes? String 1 is Java, uppercase, J. String 2 is Java with exclamation. And then we call comparative on it. I think I've seen this, but let's see how many of you remember. Any guesses? Well, in this case, it's going to return A because both strings match except for the exclamation. So there's one mismatch, right? So it'll just say there's one mismatch.
I have
Next question.
Sorry.
Yeah. Yes, go ahead.
So for the
Hello.
exclamation mark, what if it was like a different letter in for the second one as well? So if it was like a K, but it also had the exclamation mark.
Well, that's a good question. Let's try it out. Let's repurpose our existing program real quick. It just takes 5 seconds. We all are good programmers now. So we'll quickly write out and see that. So let's say that, and then comparison. And what are we comparing? So str, we're comparing str1 compared to str2, right? Then run it real quick. That's okay. Well, my bad. So the trick was it's -1, essentially because the second string str2 is bigger than string 1. But the question is still valid. What about if it had at the rate instead of exclamation? Would it give us a different result? Oh, it's still -1. What about if it had, let's say, a J again, right? Would it make any difference? It's still it's just -1, which means that what Java is doing is if there's a missing character in one of them, if there's a complete match and one is only one character off, then it just returns a +1 or -1 depending on which string has more or less characters, to say that both strings they differ by just one character, and which is the last character. Right? So let's say if that's the case, if the Java had, let's say, multiple exclamations, then we would expect that compare to will return us a count of how many characters are more in the second string, right? So instead of just saying -1, it's going to say, well, Java 2 has 4 extra characters in it.
Okay, I see.
So it matches the first few, and then this has extra 4. So it gives us an idea of how much is the difference.
Thank you.
Wait, I have a question.
Yes.
So like the output of compared to, like same number, the same number can mean different things, right? So how would we like know the reason why it's outputting which number?
Yeah, you're right. That's absolutely right. Is because if, let's say, we had here we had Java 1, let's say, and then we had Java 5 here, then we would get the same output, and there's no way to know. It'll just be -4, right? So so there could be so many combinations which would result same -4 as a result. So comparison compared to is not an exact way to find what the difference is. It tries to approximate. Now, where is the real use of comparison? Where will we use this? Generally, it's used in sorting. So if you want to sort your string, all your strings, then you would do compare to, and every time it's a negative comparison, doesn't matter how negative, you put it before the prior string. So let's say if you were comparing string 1 and 2 as str1 compared to string 2, it will tell you, it will give you a negative result, which means string 2 is bigger than string 1. Not exactly how, in what ways, but string 2 is bigger than string 1, so you should always place it before string 1 if you're trying to arrange in a descending order, or vice versa in an ascending order. So rather than looking at how much the positive or negative result is, it's mostly used to do arrangements. Like you can use that to arrange the string. So if something, let's say string 1 is bigger than string 2 by 4 characters, but bigger than string 3 by just 2 characters, then you know that if you want to arrange it, it's string 1, then string 2, and then string 3. So it's like that. So next fun question. If any more question? The last question of the day is which one of the following is true after the code executes? String 1 is new string high, string 2 is by, and string 3 is high again, but by in higher literals, and s2 equal to s3. So which one of these three are correct? S1 double equal to s2 and s1 double equal to s3, or s1 double equal to s2 and s1 equals s3, s1 not equal to s2, and s1 dot equals s3.
I think it's C.
S1 not equal to S2, you are right. And S1 equal to S3, that's right, you are right. So essentially, what the first column is doing is, it is comparing the memory location, and the second column is doing is it's comparing the content of the memory location. So when we do S1 dot equals, it is comparing the actual high sequence of characters with the sequence of characters in S3, which is also high, and that's why it's going to return true. But these two are made using two different ways. One is using literal, other is using new, so they'll have a different memory location. All right, I think that's it, the end of session today. I think we overshot by 8 minutes. Sorry for that. But we put string object to conclusive end. So string is very powerful. It's tricky too, and it's used a lot. So it's recommended you guys practice more on string methods. As you can expect some questions in AP exams. Right? Any questions?
Harry is gone. Okay.